should be the negative 1/4, negative 1/4, negative 1/4. Okay. Did I give something strange on the radius? Nope, I didn't. Okay. So for the radius, or the radii, okay, so it is going to be the square root of it. So the square root of 16, that's our 4. Square root of 75 can be simplified. So it's going to be 5 times the square root of 3. Okay? Does that make sense to everyone? Okay. You're welcome. Any other questions? Okay, so let's start into our next section. So the next section we're going to be dealing with is going to be dealing with section dealing with vectors. Okay, and as I talked about last class, once we start with vectors, it's always going to be kind of reoccurring. Vectors are always, you think that, oh, we're done with vectors, and then vectors come back into your life. So it's kind of an integral part of Calc 3. Okay, so kind of looking at the section over vectors, I give you some definitions and just some terminology and stuff at the beginning. And let me get to my beginning of my notes. Okay, so basically kind of two definitions. Basically a vector is a directed line segment. Okay, so when you think of a vector in terms of a 2-dimension, you do have a start and then you have another point here and it's going one direction. Okay, now a vector doesn't always have to start at 0, 0. The vector could be somewhere out in this, like this, and then go in the direction. Okay, so you could have it several different ways. Okay, now the way I've got the vectors drawn at the moment, they're representing a positive vector. If I had a vector going in the opposite direction, this would represent it will end up having negative values on that vector. Okay. Now, the other thing that we do with vectors is to deal with them in terms of finding the magnitude. You may also hear it, so magnitude. Sometimes, and it depends on the textbook, and I think sometimes maybe in physics, it may be referred to as the norm. Okay, and basically what you're doing is finding the distance. Okay, so let me kind of give you an idea of what the magnitude really is. And it's easy to see in a 2-dimensional vector. So in a 2-dimensional vector, if I'm given, say, this is A, this is B, so I have a start, and let's say that this is C, and this is D. And I have a value here. So I'm going from here to here in this vector. Okay, so the beginning value is what we would say is AB, and the second one would be a value of CD. Okay, so essentially what you're doing here, if I take a look at this, and I'm going to complete this out. So what I'm looking for is this, and then what I'm looking for from there is this. So when I look at this, the whole ideal of the magnitude, and if you look at this and fill it in, you're basically looking for the length of the hypotenuse because it's a right triangle. Okay. So when you're dealing with the magnitude, you're basically finding, basically in a two-dimensional aspect, finding the length of the hypotenuse. So you can find the one leg, you can find the other leg, use Pythagorean theorem, you can find the hypotenuse. Okay, and it's going to look like that when we go through and do the formula. Okay, any questions? Okay, so next I have dealing with notation. So I have the two-dimensional notation, and we have two forms that we look in the notation. So one form is the component form. So we have v sub 1 comma v sub 2. Okay, and component form is like writing it as a coordinate. Okay, but our symbol for vectors, we use kind of the less than and greater than signs. Okay, or we can write it in terms of I, J, K, or I and J components. So we can say that the vector v is equal to v sub 1 in the I direction plus v sub 2 in the j direction. Now, with the I and j direction, basically what I'm doing, instead of saying this is the x, this is the y-axis, we refer to this as the I direction. We refer to this as the j direction. Any questions? Right? And then if you look at the notes, you can see how the three-dimensional vectors, we add the component of k to it in order to get the 3D vector. Okay, and then I give you the formulas for the magnitude or the length. So if I do a two-dimensional, basically you have the formula there, and I also give you kind of the formula in terms of the ratio, in terms of the distance formula for two dimensionals, and I do the same thing with the three dimensionals. Okay. Any questions? All right, so the next thing to do is to talk about what we refer to as a unit vector. Okay, so basically the whole concept of a unit vector. So we're going to take 1 over the magnitude of a vector and then multiply it by the original vector. Okay, so basically what we're doing is taking a vector and dividing by its length. And that's what we mean by creating a unit vector. Okay. Now, the next thing we talk about is dealing with a vector made of the length and direction. So we can say that a vector v, if we want to write it in terms of length and direction, the length, which would be the magnitude, the direction is actually the unit vector. So we take the vector times, we take this times the unit vector. Now, if you look at this closely, you'll notice that, hey, these would cancel and give you back to the vector v. But this is just a different way of representing vector v, okay, in terms of its length and direction. Any questions there? And then the last thing we have in here is dealing with the midpoint. So you've talked about dealing with two-dimensional midpoint. So add up the x, take the average of the x's, comma, average of the y's. In 3D, you do the same thing. You just add that extra component, which is the z variable. So you take the average of the x's, comma, average of the y's, comma, average of the z's. Okay, hold on one second. Sorry about that. My dog decides she wants to bark at the front door. Any questions? Okay, so now let's take a look at examples. Okay, so first example that we have, oops, is this. All right, we have that vector u is defined as 3, -2, and we have vector v, which is defined as -2, 5. And the first thing we want to do is we want to find the component form and the magnitude of the vectors. Find component form and magnitude of the vector. Okay. Now, we're not going to do it of the given vectors. We're going to do some operations on them. So the first vector that we're going to deal with is -2 times vector v. Okay. So if we do the component form, essentially all you're doing is taking -2 and multiplying by each of the components. So if we do that, we're going to end up with the vector of 4, not -5. How about 4, -10? Okay. Any questions? Okay, so the B part of this.
Get 4 -10?
Say again.
How did you get it? Like, I missed how you got 4.
-2 times -2.
Oh, okay.
Okay. Any other questions? Okay, so part B is we're going to find the magnitude of 2 times vector v. Okay, so basically this is the vector, so we're going to find the magnitude of that. So the magnitude of this is going to be the square root of, it's the first component squared plus the second component squared. So we have the square root of 16 plus 100, or we're going to end up with the square root of 116, and it does break down to 2 times the square root of 29. Okay. Any questions there? Okay, so next example, still using the same 2 given vectors to help create things. All right, so the next one, and I'm going to label it B, and I'll call it part 1. That's my fault. So we're going to find -2 times vector u plus 5 times vector v. Okay, so if I take -2 times vector u, what vector will I get? So if I take -2 times vector u, what vector will I get?
-6 and +4.
Okay, so -6 and what was the other one?
4.
Yes, thank you. All right, and then plus, then I'm going to take 5 times vector v. So if I do 5 times vector v, what will I get? Don't be ashamed. Don't be shy.
-10 and 25.
Mm-hmm. So -10 comma 25. Okay. Now, so when we are adding these, okay, you basically add by components. Okay. So keep in mind that the first component is considered the I on each of them. The second component is considered the J. So basically you got to add like terms together. All right. So if we add these together, we're going to end up with negative 16, comma, 29. Okay. Any questions there? All right. So the second part is that we want to find the magnitude of this. So if we do the magnitude, it's going to be the square root of the first number we're going to have is what?
Negative 16.
Okay, so yeah, negative 16. Don't forget to square it. Plus, the second one's going to be what?
29 squared.
Yeah. Okay. All right, so we're going to do these fun calculations. 16 squared is going to give us 256. 29 squared is 841. So we're going to end up with the square root of, if I did my math correctly, 1097. Any questions there? Okay. All right. So are there any questions on what we did here, okay, with these vectors? Okay. All right. So let's move to our next example. All right. So in our next example, basically what we're going to do is we're going to find a vector, okay, and then we're going to write it in the ijk component, okay. So in this particular example, we want to find piece of 1, piece of 2, the vector piece of 1, piece of 2, if piece of 1 is defined as 1, 2, 0, and piece of 2 is defined as negative 3, 0, 5. Okay, and we're going to write it in the ijk component form. So we're going to put those ij and k units in. So if I want to find a vector piece of 1, piece of 2, okay, so the way we do this, we kind of do things backwards, okay, when we do this. So whatever's second is first, whatever's first is second. So basically what we're going to do is we're going to find the length of the thing. And it's possible that the length may be negative, which is fine. So here's how it's going to work. So for the first one, we're going to take the x values of the points and subtract them. So I'm going to do negative 3 minus 1. And that's going to be in the ith direction. Plus, then I'm going to deal with the y's. So I'm going to have 0 minus 2, and that's going to be in the jth direction. Plus, then next I'm going to deal with my z's. So I'm going to have 5 minus 0 in the kth direction. So essentially what I'm going to do is to clean this up. So it's going to be negative 4 in the ith direction, minus 2 in the jth direction, plus 5 in the kth direction. Any questions? Okay. All right, so our next example is we want to take a look at expressing a vector as a product of a length and direction. Okay, so we have vector v, which is defined as 9 in the I direction, minus 2 in the j direction, plus 6 in the k direction. Now, in this problem, and let me make sure the way I got it typed up on your in the notes, because I'm looking at some of my old notes. I think I just give you the vector and don't say it's v equals. Yeah, okay. So I do say v equals. So here's our vector. Okay. So if I want to do this, so one of the things that I have to find is I have to find the magnitude. Okay. So the magnitude is going to be the square root of, so what's going to be the first number I'm going to use?
Nine.
Yes. So it's going to be 9 squared plus the second number is going to be what?
-2 square.
Okay, good. And the last number?
6 square.
Okay. All right. Any questions there on how we got those? All right, so what we're going to do is we're going to have to end up with the square root of 81 plus 4 plus 36. Okay, so if we do that, what value we're going to end up with? Yes, we're going to end up with 11. Okay, so that's going to be our magnitude. All right, so the way we're going to rewrite this vector, okay, we're going to say that it's going to be the length, which is 11, times, okay, we're going to take the vector as it is, which is, and basically what I'm going to do is I'm going to take the vector and divide each of the pieces, each of the components by 11. So I'm going to have 9 over 11 in the I direction minus 2 over 11 in the j direction plus 6 over 11 in the k direction. So this represents, so this portion right here is our unit vector. Okay, and this portion here is the length. Okay, and the unit vector also indicates the direction. Okay, any questions? Okay, so the next thing I'm going to do is I'm going to do the last problem. The problem, it reads kind of funky. For the A part of it, you're going to find the direction of the vector piece of 1, piece of 2. For some reason, when I typed those notes, I got sidetracked and didn't type that in correctly. So, but this is essentially what we're going to do. And then the second part of it is that we're going to find the midpoint. Okay, so in this example, we're told that piece of 1 is defined as 1, 4, 5, and piece of 2 is defined as 4, -2, 7. Okay, so for A part, we're going to deal with, the direction of piece of 1, piece of 2. Okay, so we're going to deal with the direction of piece of 1, piece of 2. Now, here's what we have to do first. All right, in order to do this problem, we first got to find the vector piece of 1, piece of 2. Okay, so if we find that vector piece of 1, piece of 2, and now I'm going to do the vector in the ijk component form. So for the I component, what am I going to put inside of the parentheses right here?
4 minus 1.
Okay, so we're going to do 4 minus 1. Then we're going to have plus. Then we're going to have for our j component. So what will I put inside the parentheses here?
-2 minus -4.
Is it supposed to be, yes, is it supposed to be -4 or just -2 minus 4?
Just 4.
Okay, just 4. Okay, good. All right, and then the last one we're going to have for the k direction, in the parentheses, we're going to have what?
7 minus 5.
Yes, 7 minus 5. Okay. All right, so if we clean all this up, we're going to have 3 in the I direction minus. Now, the reason why I'm changing the sign to minus is because this is going to create a negative number. So minus 6 in the J direction plus 2 in the K direction. Okay, so we found our vector. All right, any questions there? Okay, so the next component, if we want to find for us to do the direction, we need to find the magnitude of this vector. So if we do the magnitude of this vector, it's going to be the square root of 3 squared plus -6 squared plus 2 squared. And that's going to give us a value of what? That gives us a value of 7. Excellent. So for the direction, we're going to take the vector that we just created, divide it by its magnitude. So if you see a problem that's asking you to find the direction of the vector, essentially what you're doing for a particular vector, essentially what you're doing is doing a unit vector. Okay, so if we do that, we're going to basically divide each of these components by 7. So we're going to end up with 3/7 in the I direction minus 6/7 in the J direction plus 2/7 in the K direction. Okay. Any questions there? All right, and for me not to use a whole nother page for this last little bit, and it's part B, which is wants us to find the midpoint. Okay, so for the midpoint, we're going to take the average of the x's, comma, average of the y's, comma, average of the z's. So for the x's, what value will I get?
Um, 5x.
Yes. And then for the y's, we'll get what?
1.
Yes. And for the z's, we'll get what?
6. 6.
Okay. And I know that for a lot of you, you're itching to want to put that as 2.5. Please don't. Decimals have their places, but in general, I despise them because they're harder to work with. If you can leave it in an exact fraction, it makes it easier. Now, there will be situations that the decimal does make more sense, but in general, I'm going to always say leave it in fraction form, okay? If it can be. Any questions there? Okay, so that is it for that section, 9.2 section dealing with vectors. Any questions there? Okay, so now let's move into the next section, which is going to be dealing with the dot product. Okay, so with the dot product, basically what we're doing here is we're introducing a process in order to be able to come up with a basically a scalar if we quote unquote multiply two vectors together. So if you notice in the first section, you notice I can take a vector and multiply it by a constant, and that constant we refer to as a scalar. We could add vectors together and we could subtract vectors, all right? But I never talked about multiplication, okay? And that's because really there's no true multiplication operation in vectors, okay? Now, we're going to talk about two things that are kind of like multiplication, but they're not, okay, for vectors. So the first thing we're going to talk about is the dot product. And as I said at the beginning, the dot product, when it happens, we will produce a scalar. So we're going to produce a number. The other type of multiplication we're going to talk about is what we call the cross product. And with the cross product, it's going to produce another vector. Okay, so let's take a look and show you what's going to happen here. Okay, so with the dot product, okay, so if I have, say, a vector u, oops, turn my pen off. We have a vector u that is defined as u sub 1, comma, u sub 2, comma, u sub 3. And I have a vector v, and that's equal to v sub 1, comma, v sub 2, comma, v sub 3. So if I use u dot v, okay, so now I get to kind of blow your mind and say you can't use a dot anymore, unless, especially with vectors, because it means it's a totally different operation. Okay, traditionally with numbers, that dot means that we're going to multiply things. Okay, with vectors, it becomes a whole different operation. So we have to be cautious. All right, so if we do u dot v, what that means is that I'm going to take the I components and multiply them together. Add that to the product of the j components. Add that to the product of the k components. Now, in this example, in this general formula, I'm doing it with the three-dimensional vector, but you could do the dot product with a two-dimensional vector also. Okay, so don't think that it's just it's limited to only 3D. Okay, so you can do 2, you can do 3, you can do 4. Okay, any questions there? Now, the next thing we do talk about is to deal with finding the angle between two vectors. Okay, so the angle we normally call theta, and theta is going to be equal to, it's going to be the cosine inverse of, you're going to do the dot product of the two vectors, and then you're going to divide by the magnitude of each vector. So in order to find the angle between two vectors, you do the dot product of the two vectors divided by the magnitude of each vector. Okay. Now, a little side thing, okay? If the dot product of two vectors is equal to 0, that means that we say that vector u and vector v are orthogonal. Okay, now orthogonal is just a fancy word for perpendicular. Okay. Orthogonal is just a fancy word for perpendicular. And here's why this is true. Okay, so if we do the dot product of two vectors and is equal to 0, so if I want to find the angle, all right, so that means that theta is equal to the cosine inverse of, all right, the dot product is going to be 0. Now, the magnitudes are going to be some numbers. Okay, so really we're looking at the cosine inverse of 0. Well, when is cosine equal to 0? At 90 degrees, which is a right angle. Okay, so that makes them perpendicular. Now, when we get, and we use the word perpendicular when it's two dimensionals. When it's beyond two dimensionals, we use orthogonal. So that's why there's two different words. Okay. Any questions? Okay, so the next thing I'm going to talk about is doing what we refer to as a projection. Okay, so if we do a projection, and we're going to do a projection of u, vector u, onto vector v. Okay, so here's how the projection works. So suppose that I have these vectors. So I have a vector u here, and I have this vector here that's a vector v. Okay, so the whole idea of the projection, is it's going to find, okay, I'm going to take this vector and push it down onto this vector. Now, when it does this, this is actually a perpendicular set. So what it's doing is it's taking this vector u and putting it on the vector v. Now, when we are using the formula for the projection, is we're trying to figure out what that perpendicular distance is. That perpendicular distance is the projection. Okay, that perpendicular distance is the projection. So how we find that projection is as follows. So if we do a projection of vector u onto v, the subscript means that you're going onto that particular vector. And this is equal to, you're going to do the dot product of the two vectors. You're going to divide by the magnitude of vector v and square it. And then you're going to multiply it by vector v. Okay? So essentially what's going to happen here, this component right here that we do is actually going to be a scalar. And then we're going to multiply it by the actual vector v. Any questions? Okay. Now, before I talk about the last two little pieces of this, let's go through and let's do a couple of examples just to show you, make sure we understand how to do all the stuff that I just talked about. Okay. So here are my examples. So the first example, we're given vector v is defined as 2 in the I direction plus 10 in the j direction minus 11 in the k direction. And vector u is defined as 2 in the I direction plus 2 in the j direction plus 1 in the k direction. So for the first part, for part A, I want to find v dot u. I want to find the magnitude of v and the magnitude of u. Okay, so let's start off first dealing with v dot u. Okay, so if I do that, all right, so what are the first two things I'm going to be multiplying together?
2 and 2.
Okay, so we're going to do 2 times 2, and we're going to do plus. So what's the next two things we're going to multiply together?
10 and 2.
Okay, and then plus, what's the last two things?
Negative 11 and 1.
Okay. All right, so if I multiply this out and add it together, what value will I get?
$13.
So that would be the dot product of this. Now, here's the nice thing about the dot product, which I don't really stress or anything like that. The dot product is commutative. So v dot u is the same as u dot v. It's going to give you the exact same answer. Okay. All right. So the next piece of this, I'm going to switch colors. We're going to find the magnitude of vector v. Okay. So that's going to be the square root of, so the first number we're going to have is what?
Two.
Okay, so we're going to have 2 squared plus the next one is going to be what?
10 squared.
Okay, and the next one's going to be what?
Negative 11 squared.
Mm-hmm. Okay. All right, so if we simplify that, what value do we get?
$15.
Yes. Okay. All right, and then the last thing we're going to do is we're going to look at the magnitude of vector v. Okay, so we're going to have the square root of, all right, so we're going to do 2 squared plus 2 squared plus 1 squared, and we're going to end up with a value of 3 when we do that calculation. Any questions so far? Okay. All right, so next, let's move to part B of this. So part B is to find the angle between the vectors. Okay, so if we're looking for the angle between the vectors, and essentially the formula, the way it looks actually, is that it's the cosine of theta is equal to the dot product of the two vectors divided by the magnitude of each vector. Okay, now we said that the dot product was what?
13.
Okay, we said the dot product is 13. We said that the magnitude of vector u was what?
3.
And then the magnitude of vector v was what?
15.
Okay. All right. So basically we're looking at 13 over 45. So if we want to find theta, we take the cosine inverse of both sides. So theta is going to be the cosine inverse of 13 over 45. Now, when we're doing this, you can work with radians, but it works better with the degrees. So you can have either answer, okay, and just make sure you pay attention to how the question is worded. If it says give the answer in degrees, give it in degrees. If it says give it in radians, give it in radians. Okay. So if I look at this, for radians, it's going to be 1.278 radians. Degrees, it's going to be 73.21 degrees. And hopefully I didn't screw up my work. Everyone agree with that?
Yeah, I got the same.
Okay. Any questions?
Just to double check, you said you want the answer in degrees or radians for like a quiz.
It doesn't really matter to me. Just pay attention to the way the question asks. If the question doesn't specify, I don't really care.
Thank you.
I'm very flexible.
Awesome.
Okay. Any other questions? Okay. So the next part of this question is asking the scalar component of u in the direction of vector v. Okay, so this is kind of dealing with the last two formulas, and basically what I'm going to do is I don't need the left-hand side of the equation. So in the equation, you have that the magnitude of vector u times the cosine of theta is equal to u dot v over the magnitude of v, which that's also equal to u dot v over the magnitude of vector v. Excuse me. Okay, so the piece that we need in order to work this particular problem out is just this value here. That's going to be the scalar. Okay, so we're going to use that in order to come up with the answer. All right. Yeah, I don't know why I decided I wanted to go back several pages. Go for it. So if I do that, we already established what the dot product is. We said the dot product is 13 divided by. We've already established what the magnitude of vector v is. We said it was 15. And that's our answer. Okay. Any questions? Okay, so hopefully everyone's got the notes in front of them. So what I want you to do at this time, okay, I want you to read the application example, okay, and based on reading the example, see if you can come up with a drawing of what it's talking about. And I'll give you a couple of minutes if you want to chit chat amongst each other to kind of help each other out. And once someone feels like they have it, what I'll do is, if you have a pencil, I'll give you access to draw it on the whiteboard. So I'll give you a couple of minutes. And during this time frame, this is kind of your break time also. So if you need to get up, run to the restroom or anything like that, or get something to drink, you can do that at this time. I will tell you right now, which I forgot to tell you on the first day, I typically am not going to talk for an hour and 15 minutes. you guys will want to kill me and I will want to kill myself. So this is kind of the break time now. Okay.